All right, welcome back. We are GAME3001. That's Game AI in the summer 2021 semester at George Brown, and it's week 2, part 2 of our broadcast. I'm talking about, I'm showing you guys everything you need for Lab 2, and also it's going to help you with a bit of Assignment 1. All right, so to start off, what I'd like to do is let's go into the things that I want to do today. And I kind of started with the last class. So I'll undo these things because we haven't done this yet. So this is kind of our plan for today. We're going to clean the play scene. We're going to add a target game object to the play scene. We're going to create a Starship game object, add that in, do basic movement, begin the seek algorithm, and we're going to adjust IMGUI for all this stuff. Okay, so that's what the goal of Lab 2 is. All right, so that is what we're going to be doing now. First things first, though, let's download the framework. So up online, what I've done is if you go to Labs on the left, there is this assignment framework right here. I've updated it, and if you actually go up there, you're going to see that the assignment framework, SDL Engine, has been updated to version 0.26. So please re-download this. There's two ways to get this. You can get it from here, code, and download zip, or what you can do is you can just go to this. I recommend this way. Go to the releases, go to SDL Engine version 0.26, and then download the source code from here. When you do, what you're going to see is, not this, we're going to put this inside of our, in my case, desktop, GBC, GAME3001, summer 2021. I've got this downloaded right now, and I'm going to expand this or unzip it. And I'm going to extract it here, okay? And when I do so, right, I'm going to change the name. Let's do that. So let's change the name of this. So it's Lab 2B. And under Lab 2B, this is where this is. We've kind of expanded this thing. So unzipped it, and this is where we're going to start off. Okay, so please download the assignment framework and unzip it somewhere where you can use it. We're going to make it Lab 2B because you guys are the B team. Let's start off by double-clicking on my template.sln. And when I do that, in my template.sln, it's going to come up with this screen. Most likely, you'll also see something that looks like this. All right. What we want is we want to move, when we first start off downloading our template, we want to move from x64 to x86. Let's do that first. And after x86, we want to go to, on the right-hand side under Solution Explorer, right-click and retarget our solution. So do that there. And then this will retarget your SDK, so it points to the Windows SDK that you've installed or that's been installed on your system. Press OK. And that is the first step. Okay, at this point, I'm going to ask, are you with me? For the people that are here, do you guys have everything like I have? Have you downloaded and installed the framework right now? And if you have, check mark. Thank you, Lyra. And if you haven't, or if you need more time, press an X and I will hold off. Daniel, thank you. And for the rest, I hope you guys are able to catch up. All right, I'm going to move on. I'm hoping that you guys have it. Lewis says, could you repeat the step for retargeting the solution? Sure. So the way you do that, Lewis, is you would go to right-click on your solution, and then you're going to go to retarget solution. Okay? That's all you do. Next step, let's run it and see if it works. So what I've done with this framework is I've updated it, I've removed a bug. I've also uploaded the latest version of IMGUI from the lab framework that's online on GitHub. And so it adds additional functionality. Hopefully this will be, it'll help us in future iterations of our code. So let's take a look at that. So when I click Start, you can see that I can go to a little silly scene that we've created here. And if I press the backtick character, we'll have our little utility window that'll come up. And that utility window doesn't really do much right now. We have this scene that comes up. So this is a good check to see if everything is working as it should. Excellent. What we want to do now is I want to clean up our scene, our playscene.cpp, similar to what we did last week. So this is a bit of a repeat and review of what we did last week. Let's do that. So I'm going to go into scenes. I'm going to go into my playscene.h. And here's where we're going to do some cleaning up. I'm going to remove all of these items. Under the playscene.h, I'm going to remove all of this. Okay, that means the plane, the player, the how they're facing right or not, you know, the button, label, all this stuff is going to be gone. Okay, and press delete. And what this is going to do is going to cause errors in your playscene.cpp, but we want that because we want to remove all of this stuff anyway. So let's do that. So we're going to scroll down and we want to remove all of this, anything that's in the handle events function, from about line 39 all the way down to just before the isKeyDown event for the escape key. I want to delete all that. Okay, so now your handle events function will only have these keys. Just scan code, escape 1 and 2. And let's get rid of the 1 and 2. We don't need them right now. You can always add them back in later. All right, so that is our scan code escape. We also have all of these things. We don't have a plane sprite or a player or a back button or any of this stuff. Let's get rid of all this stuff up to, and not just on top of the IMGUI window frame. So not including the IMGUI window frame. So let's get rid of all that. So now your main start scene looks like this. So there's your handle events function. It's a much smaller function. And your start scene just looks like this right here with nothing in it. I also want to change our docs. Here's our documentation. Let's change our README file. I'm just double clicking on my README file. This is the README file for the engine. We want to make this README file for you. Let's get rid of everything in the README file except for the heading. And let's change the heading so that it is the lab. So it's going to be GAME3001 in the summer 2021 semester. And it is lab 2. And we can say for a description, demo project for GAME3001 lab 2. Okay, that's your README file. The README file is just a file that's going to show up on GitHub, on your GitHub. All right, so now that we have this, let's test our scene and make sure that it's empty and there's no errors. So run it. All we've done is remove stuff. And if everything goes well, we shouldn't have an error. We're going to build the scene, and we're going to go to Start Scene, and it should be empty. If you press IMGUI, the backtick character, it should come up with this little utility window that doesn't do anything right now. This is a great start. This is our default start level, and I want to put this up on GitHub. In order for me to do that, I'm going to click on Team Explorer. Actually, let's go back. I'm going to right-click on my solution template, and I'm going to go down to Create Git Repository up here. This is new for Visual Studio 2019. I didn't add anything here. If I go to Extensions, and if I go to Manage Extensions here, you can see that under my installed extensions, the only thing I have for installed extensions are the ones that show here. These are the ones that have been installed with Visual Studio. Okay, so there's nothing that's odd that's been installed here, right? So Visual Studio Rich Navigation, Web Live Preview, Test Adapter for Boost. These are all things that got installed when I installed Visual Studio. And there's also this one, and this is a key one, GitHub extension for Visual Studio. If somehow or another this has not been included, please download and install this extension. And you get this by going into Online, and then you'd search for GitHub. Let's search for that together. So just in case you don't have it, it will come up with this extension right here. And what you would do, you would have a download button that would be appearing here, and then you download and install the GitHub extension if you don't have it already. Okay. By the way, notice that there are some updates to extensions that I already have. For example, the GLSL language integration, I could update that, and the ML.NET model builder preview, I could update that. I'm not going to do that at this point. I don't need to. So that is the extension that I'm going to use right now. I'm going to go into right-click my Solution Explorer and go into Create Git Repository. That's how I'm going to get this. And when I do, it's going to give me this little wizard that comes up. And this little dialog box is showing me the local path to my repository, the account that I'm using, and my owner, which is me. I'm going to point to George Brown College, and I'm going to change the name of my repository to match the name of my project, which is going to be GAME3001 in the summer 2021 semester, and it's Lab 2B. You guys are the B team. I'm going to leave it as private, as you should, and I'll show you how to take it out of private and make it public after, which is what I need to do. I'm going to create and push, and this is going to create an initial push to GitHub. Let's do it. It may ask you to log in for the first time if you've never done this. Okay, we're good. Let's see if we've got it on GitHub now. So I'm going to go up to GitHub. And under GitHub, you can see that on George Brown College, I have two labs, Lab 2A and Lab 2B. Lab 2A is public. Lab 2B is private. I want to make it public. In your case, for you to make it private, make sure you include me as a collaborator. And I'll show you how to do that again right now. I'm going to click on Lab 2B on GitHub. Well, I've got to show you some stuff other ways, Lyra. That's why, right? So you know both ways. So here I am, right here. And this is Lab 2. And what I want to do with this one is I want to change this. I'm going to go to Settings. And under Settings, I'm going to go to Manage Access. So for you guys, if you made yours private like me, you need to invite teams or people. Click this link under Manage Access, under Settings, right? Invite teams or people. And what you're going to do here is you're going to invite me. So you're going to start typing in Ciliopoulos@hotmail.com. You'll see that only one name comes up. That's my name. And you'd include my name here and click Add Me to the repository. Yeah, that's what you'll do. When you do this, you want to give me only read access. You don't need to give me anything more than this, right? As an example, because I only need to read your repository, not write to it. I'm not going to write or maintain or triage it. So just read is enough. If you want to give me write, it's okay, but it doesn't really matter. As long as I have access to your repository to at least read it, I'm good. Then click Add It. It'll send me an email, then I can add you in. For now, I'm not going to do that. And I'm going to actually switch my repository so that it is public. And the way to do that is go to Settings, and underneath that, scroll all the way down until you get to the danger zone. If you're going to make the repository public, which I'm asking you not to do, don't do this, right? Then you go to Change Visibility, and you can type in the name of your, or copy paste the name of your repository here, copy and paste, and then it says, I understand change repository visibility. And when you've done that, it will change the repository from public. Let's try that again. From public to private, and then it'll be good to go. Okay, if you already made it public, you can make it private in that way. All right, that's how you do it. Just in case you don't have to make a whole new repository. It's not required. Awesome. This is great. So this is the first step. You did your repository. You should have already sent this to me as a request, an email. If you've done this right now, we're well on their way. You can get part marks just by doing what you just did right now. Next, we need to do some more changes. This is not enough. This is the beginning. So right now, what we've done is we've done this. Clean the placing. Let's add a target game object to the placing. Let's do that now. So this is part 2. So what do we do there? How do I add something to the placing? Well, I want to go to placing.h, and in here, I have some stuff I can remove. I don't care about label, button, player, or plane. I don't need this stuff. But I do want to include a target. So there's two ways to do that. I can include a target there, or I can just start typing. Let's just say these are game objects. And I want to say that I want a new target game object, target pointer. And when I do that, resharp or C++ comes up with an option. It says import type. What do you want? Do you want a forward declaration for target, or do you want to include target? I want to include it. It includes it here automatically for me. And then I can say m_p target is the name of my variable for the game object. Once I've done this, now I need to include it in my placing.cpp. So I go to my placing.cpp and go where it says start. And this is what you do when you want to add a game object that already exists. I already made this one for you. So you can do this too. I want to say I want to add target to scene. Right? I want to say m_p target is equal to a new target. I'm using the new keyword, which means I'm allocating memory on the heap, and I'm returning a pointer to that memory and storing it in the m_p target identifier variable. Then what I want to do is I want to specify where the target is going to be located. And I'm just going to draw a little, I've already done this here. So here is where the target is going to be. It is, my screen is 800 pixels by 600 pixels tall. I want to put the target somewhere over here, let's say, and this should be somewhere around 600 pixels on the x-axis and 300 pixels on the y-axis, somewhere in here, right? 600 by 300. So that's what it's going to be. So let's do that. So I'm going to say that m_p target, and then we'll say get transform dot position. That's going to equal to a new GLM vec2 object that's going to be 600.0f and 300.0f. That is my target position. And then in order for me to see it, I need to add it to the scene. So I'm going to say add child m_p target, and that will add the target to the scene. Whenever I use add child, because my target is a display object, what it will do is it will update in the display list. So it will update the display list and draw the display list. That's what add child does. It adds it into the display list for the scene, and then every frame it just updates its position and it draws it. So if I just do this and if I press play now, we should see. One sec, I'll do that in a second, Lyra. We should see this. That's the target. So here's the placing.h right now. So that's the target. We've added the target to the scene. And let's put that up on GitHub. We've actually been successful in adding it on. But I also want to be able to control the target so I can move it around with IMGUI. Let's do that next. So I'm going to go back to placing.cpp. And I'm going to scroll down to the GUI function in here, and I'm going to remove all this junk from inside of the this part here. I'm going to change the float3. I'm going to right-click, and I'm going to refactor, rename, and I'm going to rename this float3 to target position. Target position is something that I want to keep track of. So in here, what is it telling me? No, I want to change this to 2. I want to reduce this to this, and I want to set the target position to the target position. I did it differently in the other class, but what I really should do here is basically get the target position from the current position right away. So I'm going to say something like m_p target, and then get transform dot position dot x and m_p target. And then get transform.position.y. And those two values are going to be the values that I'm going to use inside of the target position variable that's in here that I'm going to modify. So that's where it starts. And I'm going to change this from a float3 to a float2. So a slider float that only has 2 parts. And I'm going to say that this is my target position. Okay, that's what it's going to be. The range, this is the range, right? the range is going to go from 0 to, let's say, something like 800. So I can move it 800 pixels in any direction. And then when I move this, I want the M_target transform position, copy this, to equal to a new GLM vec2 object that is going to be the target position 0 and the target position 1. And this is going to do very similar things to what we did last time, when we did this exact same thing for the spaceship. Lewis says, my target isn't rendering. Lewis, the only way the target isn't rendering is if you haven't added child. You have to add child and make sure you put it in the right position. If you don't do add child, it'll never render. All right, let's see if this works now. And when we do that, we're going to press play. And when we do, if everything goes well, we're going to be not only able to show the target, but we should be able to control the target by moving this around. So if I go, I want to move this here or here, I should be able to move the target anywhere around on the screen. Okay, so that is the target. This is good. I'm going to add this to the scene, and where it says your window title goes here, let's change this window title so it's right. So it's going to say Game 3001 in the summer 2021 semester, and it's Lab 3. Lab 2, I'll be okay. And let's see how this looks one more time. So if I run this thing, and just to make sure that before I put it up on GitHub, so I can bring this up and you can see that there it is. There's that thing. Now notice one thing it did. It moved it and I can't move this part. I mean, I can certainly expand this, but why is this in the middle? Well, because I changed the title and I made it so it's locked. So it says no move. You can change this window flag so it doesn't say no move. You can just remove this thing. One thing I do like is that the window flag should be a utility window, and you can do that too. You can say I am GUI window flags, and then what you want is for it to be a utility window. Again, it's not really necessary, but you can basically say that this is these are the window flags you can activate, right? Vertical scroll, nav flattened, no collapse, no inputs, and so on, no title bar. These are all things that you can remove and all that kind of stuff. I'm not going to do that though. I'm just going to put in so that there's none of this stuff. And you can have something that looks like this. Null, it wants you to put in null pointer. I'm okay with null pointer. It's not going to make a difference. It just equates to 0 at the end. And if I did this and ran it again one more time, then if I go back to start, and if I pull up the window, I should be able to move this window around with no effort. And I can put it wherever I want. If you want to make this window bigger to start, let's say, for example, this is pretty big, you can do that somewhere else. I won't show you today, but there's another place you can do that. So you can change the window size that I have here. For now, it's done in another place. Later on, what I'll do is I can set the window size somewhere else. Okay? So now you can still do this. Let's put this up on GitHub. So the way to do that is go to Team Explorer. Again, to get Team Explorer, you can go to Window, View, and then you can go to Team Explorer. So that gets you to Team Explorer. I'm going to go to Git Changes, and under Git Changes, I'm going to say Added Target Game Object. Okay? And then you can also say to placing, where'd you add it, right? And then commit all. And then after you've done committing all, you can press this up button, this push button. It may ask you to log in for the first time. So push, and then what it'll do is ask you to log in again. And right now, you should have the latest version up online. So let's take a look at that. If I go up here to GitHub, and if I go to here, then you can see that 25 seconds ago, I pushed this commit. And you can see that I have 2 commits here, and that I have these 2 files. I added my project files. This is like git init, initial commit. And this is me adding my target game object to the play scene. That's me doing all these things, right? For now, to make it easier for you to see this stuff, what I'm going to do is I'm going to grab this link right here, and I'm going to go to Content, and I'm going to go to Lab 2, and I'm going to call this a new link, web link, which is going to be, I'm going to copy that. I'm going to say GitHub link, or I'll say Lab 2 GitHub link final. All right, so that way you know it's the final version that I'm doing this week. And then I'll take this link and I'll put it up here. So you should have that on GitHub and on Blackboard. All right, are you with me? If you are, check mark. If you're not, X. Okay, I see Drake is with me. Daniel says, it says that push to my GitHub, but I don't see the new commit. You need to check to see where it went, Daniel. Sometimes you might have gone somewhere else. Maybe you didn't push it. Maybe just refresh. Maybe make sure you refresh your page. It doesn't automatically refresh when you push. So over here, when you go to your page over here, just refresh. Refresh the link. Refresh. Okay, so if I press refresh, it'll refresh the link and it'll give you the whatever commits I have. This is Lab 2A. You can see that I did 4 commits, and if Lab 2B, I only have 2 commits. All right, good. Thank you for that. Let's move on. So now, step 2. So now that we've done that, we've done this piece. We've added our target game object to the play scene. Let's now create a new Starship game object and add that to the play scene. So how do I do that? That's a little trickier to do. Not much, but a little. Let's go into it. So again, go to my Solution Explorer here, and I want to add a brand new game object. To prepare for this, what I've done is I've given you an image. So if you go up on Blackboard, there is an image called NCL. If you click on that image, you'll see what it looks like. It looks like a little picture of a starship from Star Trek. NCL, by the way, for those people who are interested, stands for New Light Cruiser. That's what it is. New Light Cruiser. And the New Light Cruiser was actually featured in a movie in 1982, Wrath of Khan. That's what this thing is. But who cares? I'm just a Trek fan, so that's where this is. But that's the image we're going to use today. I'm going to put this on inside of our project, and you can download that link right here. You can go here and download that image, right? And that's the image I'm going to use today. I put this up on Blackboard for you. But for me, what I need to do is I need to go over to my downloads, grab that image, copy it, and then in my desktop, go back to GBC, go to 3001, go to M2021, go to Lab 2B, go to Assets and Textures, and this is where I'm going to put it, in here. So Control V, and there's that image. Notice that the image, that if I hover over it, it tells me that the image size is 101 by 54, 101 by 54, right? So I didn't make it completely like squarish like this one, 65 by 65. I made it on purpose irregularly shaped because it's going to give us some issues, and I want you to be able to deal with issues when an object is not square or round. That's why I've done this. Okay, cool. So we've got our image. Now we can start programming the game object. How do we do that? Well, I want to start by going to Game Objects, and I want to right-click. Let's close these down for now, so there's nothing up open. Let's right-click on Game Objects, and I'm going to click on Add New Item. Now, you might be forgiven to think that if I go to Class, I can add a new class, and it'll go to the right place. Please do not add a class. Add the header and CPP file separately. Let's start with the header. So I'm going to click on Header, and down in here where it says Template, this is not the correct location. You need to select Browse, go up to Lab 2B, and click on the SRC folder. and click select. What this does is this is the new link. You can also modify this manually by yourself without going to browse. Okay, so that's definitely another thing you can do here, right? Notice that there are no other links that you can select. You need to change this so that it's the SRC folder. If you don't, you'll never be able to find your new class. Okay, so that's your .h. Let's rename this .h Starship.h. And then click Add. It's going to add a new object right here. Let's add another one. Add a new item, and instead of a header, let's add a CPP file, and let's call it the same name, starship.cpp. And make sure it goes in the SRC folder. Notice that it remembered that I chose the SRC folder last time, and it's going to go in the same spot this time. Click Add. So now I have both the .cpp and the .h. Let's immediately add an include in the .cpp to reference the .h. So we're going to do in here, and we're going to say include, and we're going to say starship.h. What this will do is when we add new things to the Starship class, right, I can implement the details inside of the .cpp as long as I've already referenced it. Let's go back to the starship.h now and add the new class details. First, we want to start with a guard. And we're going to start with this. If not defined, Starship, then I want to define Starship. And I want to end if, right? And end if, I'm going to say defined, just a little comment, Starship. Okay, so that is my guard function. Someone asked earlier, why don't we just use pragma once? Pragma once is good enough for a MSVC, the C++ compiler that's in Microsoft. But if I want to use my files cross-platforms to work on Mac and Linux machines, the pragma once will not work. That's why we need to use if not defined, define, and end if, right? All right, so let's go on and let's make a new class. We're going to call it Starship, and we're going to extend a public other class. Which class should I extend? Because I don't want to go make a brand new object from nowhere. That doesn't make sense. I already have classes I can use, and I have a bunch of them. Let's take a look at some examples in the core filter. One of them is display object. So display object, what it does is it adds, allows you to get and set parent if you want. I can also get the layer index and get the layer order index. I can also set the layer index here, okay? So these are the things that the get set functions allow me to do with display object. That's pretty cool, but it's basic. It doesn't do anything else much more than the game object superclass. So the game object superclass, which is here, is the base class for all game objects. And I talked about this last week. It has get width, height, enable, disabled, invisible, and so on. All right, that's all this stuff. Cool, excellent. But there's another class I added called agent. And what agent does is agent actually extends the display object superclass, but it adds a couple of different things. Get target position, get current direction. I also have line of sight and a bunch of other stuff. This is the better class to start with because it has additional functionality that we might need with my Starship. So let's make Starship extend the agent superclass. So the way to do that is I'm going to go public agent, and I'm going to press my control. This is also going to tell me, hey, you need to include the agent.h file. If you don't have a ReSharp or C++, you won't get these little prompts. And I talked about ReSharp or C++ last week, right? If you don't though, you can always do this manually, which is what some people did today. Cool. So now I need is two things, a public area and a private area. And you know what? Instead of reinventing the wheel, we have examples of agent that exist. But one thing I could do is I could implement the class functions that are not implemented here yet. Let's do that. So go to the little hammer, and it says generate missing members. Let's do that. Generate missing members. It allows me to implement the draw, update, and clean functions, which I will click finish. And then what this will do is we'll add the definitions for these right here. And these are lifecycle functions. So these are display object lifecycle functions. That's what they are, right? I also want to include my constructors, if there's more than one, and my destructor. Okay? My constructor that I'm going to add in is just going to say Starship for now. And my destructor is just going to be the regular destructor. Okay? So those are the basic things I need right now. Okay? Let's implement these on the CPP side. Right now, the CPP side is pretty empty and lonely. Let's add them in. So I'm going to hover over my class. And again, I'm going to use ReSharper C++. I'm going to click on the little light bulb. And I'm going to say, generate definitions by declarations. And when I do that, this little wizard comes up. This is only a ReSharper wizard. And then I'm going to click on finish. But notice that there's also an option for generate inline definitions. What this would do is it would generate the definitions in one file, which we will not do. I'm always going to be using a .h and a .cpp throughout the entire evolution of our code. Let's press finish. So now you can see that it's put in some stubs for the .cpp file for starship.h. And let's just make our Starship destructor default for now. Okay. And we already have an example of an agent that we can use to build up our constructor function. Let's do that now. So we have an agent that we use called ship. That's what I use. And I use that in the start scene. You can always see that already if you go to the start scene. So ship is what I want. I want to double click it. And I want to do a side-by-side view. And the way to do side-by-side is you take the tab and drag it, and then you drag it on top of this little cross. Depending on where you drag it, if you do it here, it will do a side-by-side on the right side. If you do it here, it'll do a side-by-side on the left side. If you do it here, the top, here, the bottom. So I want to do it on this side. And I want to hide my Solution Explorer by unchecking this little pin. And now I have my side-by-side view of my ship.h on the right and my starship.cpp on the left. Let's make my ship.cpp on the right too. So I'm going to go back to my Solution Explorer and double click on my ship.cpp. And if it appears here, you can always just drag and drop this to this side. So now I have an example of what a constructor would look like of my from my class, right? So this is my ship class. A couple things that I note here that I've added. I've added my play scene, which right now I don't need, and I've got my texture manager and util.h. Let's add in for sure these two, my texture manager and util.h. Let's grab those two, copy them, and go back to starship.h and add them in. Why? Because in my Starship constructor, I definitely want to load the image from my Starship. And so I'm going to grab this image right here, and I'll explain what this does. So this one, Texture Manager, I call the Texture Manager I defined last week. I say, hey, Texture Manager, go through your instance portal and load my Starship. But it looks like this, Assets, Textures, and this should be NCL. That's what I called it, remember? NCL.png. And let's make a friendly name for it, and we'll call this friendly name Starship. Now, if your Starship gives you a underscore like this, it doesn't like the name. See, it has an A there. And what we can do is we can just add to user dictionary for this template, so it doesn't complain. Are you guys not hearing me anymore? Hello? Okay, good. Not sure what happened there. Anyways, the good thing is I'm still broadcasting for 30 seconds. Wow, that's crazy. I didn't notice that. All I've done is I've constructed this new class, and I'm basing it on the agent superclass, and I'm modeling after the ship CPP. And on the left, I'm just basically saying, hey, this is an example of what I can do on the left for my Starship. Okay. I definitely need this auto size and set width and set height. I'm going to copy this. And again, I'm going to go over here and I'm going to paste it. But we need to get the texture size from the Starship. So what is get texture size? I made a function in Texture Manager to automatically read the size of the texture and set the width and the height so it's that size. So instead of me putting it manually, because that would be very bad, I'm just getting the size of the texture from the Starship texture itself. Once I've done this, I'm well on my way to do other things. I can set the position of the transform, my velocity, and everything else. Right now, I only care about these three things for my rigid body, but not the transform. I'll set that transform somewhere else. So just grab these lines of code here and just paste them below. So what I'm saying here is my velocity initially starts off at 0. My acceleration starts off at 0. Is my object colliding by default? No. And my type is an agent. If I looked up what that is, if I right click and go to definition, you can see that I have an enumeration type of agent, path node, spaceship. I can make my own, but for now I'm just going to leave it as agent. Because both of them are different kinds of agents, but they're agents. And so far so good. Turn rate is something we need. And max speed is something we need, but we don't have those defined. If I go to my ship.h, notice that my max speed and turn rate are some things that we have here. Let us take these two variables. Notice that the Starship and the ship are very similar. And I'm just building it out for you so you see how we do it. I'm going to go to starship.h, and in the private area, I want to type in float m underscore max speed and float m underscore turn rate. And inside my starship.cpp, there's two ways to initialize those things. I could go up here and use the initializer syntax like this, colon, m underscore max speed and turn rate. I could do it up here. That's acceptable. Or, because this is the constructor, or I could just do them individually down here. It's up to you. The former way is the better way to do it, right? So I could say something like m underscore max speed is equal to 10.0f. So that is 10 pixels per frame. That's what I'm trying to do there. And let's make sure I put a semicolon in there. And I could say that turn rate is equal to 5.0f. And I can put a comment here that is, again, 5 degrees per frame. That's why I'm turning. My turn rate is 5 degrees per frame max. So I've set up the constructor function with everything I need for the Starship to get going. But notice the difference is I've renamed the Starship from ship, because that's what it was. That's what the other object was called, to Starship. This is an identifier that accesses the dictionary that I use in my texture manager. Notice when I go to my texture manager, if I go to definition, just like I said last week, that inside there at the bottom, there is a texture. So a texture map, which is really a dictionary that holds references to each of the textures that I load. So I don't have to load them more than once. So that's what this is. This is a friendly name for the texture that I'm storing in the dictionary. And that's why I have to pull it up here again. Great, now for the draw function. Notice that I created an alias for X and Y. I recommend you do that as well. So I'm going to copy those. And what this is, it says, hey, let's get the transform position. This is where I want to draw the object. I'm going to draw it where it's positioned. You don't have to, but it makes sense that you draw the object where the object is positioned in your coordinate space. So that's what I'm doing here. First thing is I'm getting the X and Y coordinates. Next, I want to draw the ship. That's what this part is. And let's talk about this for a second. So what I want to do here is I want to draw the Starship. And this should say, of course, not ship, but Starship, because that is the object that I'm drawing. Starship is the friendly name for the texture that I've saved inside of the texture manager, like I said earlier. I don't need to draw the line of sight line, so this is all I need for this. And I'm not going to add in any other functions right here. So this is all I need right now to make my Starship appear in my scene. I don't need these things anymore. So let's just close them off for now. But one thing I would like is if I have turn speed, turn rate, and max speed, I might want to get those functions, or I might want to get these variables outside of my Starship. So I'm going to create getters and setters for this. Let's do that now. So on the Starship, let's go inside of the public area and make getters and setters. These are get accessors and set mutators. That's what they're called. So I'm going to get a getter, which is going to return a float get max speed. Okay. And I'm also going to do a float get turn rate. I'm also going to get a void set max speed, where we pass in a float that is a speed that we want, and void set turn rate, if I want to modify the turn rate, which is my angle. Okay, so those are my getters and setters. And of course, I need to implement those on the CPP side, but we can use ReSharper or C++ to do that for us. So going here, going to the light bulb, going to generate definitions by declarations. It's going to generate this little dialog box, and then click Finish. And what this is going to do is going to generate my stubs in here for all the things we want. So for the get max speed, I'm going to return m underscore max speed. For the turn rate, I'm going to return m underscore turn rate. For the setter, I'm going to say that m underscore max speed is equal to speed. And for the setter for turn rate, I'm going to say that m underscore turn rate is equal to angle. Now, there's some suggestions that I can take from ReSharper. It says that I should make my get max speed and get turn rate const. Let's do that. Let's make the member functions const. And I can also set max speed. I can make this parameter const and this one const. These are good suggestions from ReSharper. It makes our code safer. Cool. We have pretty much everything we need now to make our Starship class complete. Let me show you the entire listing for those people who need it. So here's the top. This is again, the Starship Constructor. Pretty much very similar to what we did with our ship constructor, right? And here at the bottom, we have our draw function, which draws the Starship in its location, where it's located. We also, the draw function also says that it takes an angle. The current heading is the angle, wherever it's heading. And as well, we want to see that we want to set that it's fully opaque. So that's the alpha transparency. And that it is centered. Centered means that is where the this is where the anchor is going to be. So what I mean by that is, by default for the ship, typically the anchor is on the top left corner, like up here, right, for all game objects. But what I've done is I've moved it in here in the middle. So when I rotate, it'll rotate from the middle of the ship, not from the corner. Okay. So that's what this true means in draw. The draw function will draw the object from the middle. Okay, that's what it does. And I've set that up for you. Okay, this is great. And then all these are our setters and getters for everything else. So that's something that I've added. Let's add this Starship as an example into the playscene.cpp. So I'm going to go to Solution Explorer, and I'm going to go to playscene.h, and let's add the Starship in here first. So playscene.h, I want to say that Starship pointer is m_p Starship. And it's going to say, hey, do you want to add my Starship to the includes? And of course, I'm going to say yes. So it's going to add Starship to the includes. Once I've done that, what I want to do is going back to the playscene.cpp now. I want to go down, scroll down to where it says my start scene. And I want to do something very similar to what I did with the target. I want to add the Starship here. So I'm going to say add Starship to scene. And it's going to be m_p Starship is equal to a new Starship. And m_p Starship. And we're going to say get transform dot position. That's going to equal to a new GLM vec2 object, which in this case is not going to be 600 and 300. That is on the right. I want to make it on the left. This is the center. So if this is 400, then this would be something like 200. I'm just eyeballing it. 200 by 300 is where the Starship would start off. So again, that's what the position is going to be. 200 by 300. Okay, that's where the Starship's going to start off. And now I've got to add it to the scene with add child. So I say add child m_p Starship. And if everything goes well, we should be able to launch everything and see the Starship in the correct place, facing in the right direction. Yeah, give me 1 second, Lara. I'll do that right now once I finish launching. Right? That's what you should see. Let's go back to do what Lyra asked, which was show the setter definition for the Starship.h. So this is the getters and setters definition, and then you want to see the getter and setter declaration. I'll put this on the side so you can see everything side by side. How's that? Are we good? Is everyone with me? If you're with me, check mark. Daniel's got an X. Daniel, what's the issue? What are you seeing? Lyra, you're good. Drake, you're good. Daniel, what's the problem that you're having? Just need a line from placing. Okay, which line? Where do you want me to go? In the CPP or the H? Okay. Is that what you needed? Excellent. So now this is everything you need. We've created our new Starship and we've added it to the scene. Let's run it one more time to make sure this is good. And when we do, I'm just gonna move these out of the way so you can still see the code. And when we start, you can see that we have this. We can still use our little utility window to move our target around. And notice it appears underneath the Starship. Why? Because we added it first. This adds in additive order. So I add the first one, and then I add the second one. And by default, I can change that order. But by default, the Starship is painted after the target. And so that's why it appears on top of the target. Awesome. All right, let's put this up on GitHub. So again, I'm going to go to Team Explorer. I'm going to go to Git Changes. I'm going to say added Starship to placing. I could have done another commit that says created Starship, but this I'm just making a new one and adding it at the same time. Commit all and push. Okay, so that's what that does. And if we go back to our little thing, we just did these pieces. Okay, let's talk about basic movement and seeking algorithm and adjusting the IM GUI and what to do. All right, so we want to use the seek algorithm, and I'm going to refer back to our little stuff online. So online, remember I referred this to you, which is this steering behavior example, right? And this is a great little example. I'm going to copy it and paste it into our chat window. This is it. So you should see that now. And what it does is it actually gives us a little bit of code. So this is some code. Now I'm going to start seek for you. You have additional things to do after this. And that's why I said in the PowerPoint, we're going to begin seek algorithm. I'm not going to give you everything because you're getting marks for all this stuff, but I will start things for you, and which is what I've done here so far. All right. So remember that the labs that I'm trying to do with you guys should help you format or start off your assignments. That's what I'm trying to do with you. So each assignment that we're doing together, I'm starting them off for you. And then your job is to finish them off, okay? Which takes some time, sometimes some research, you know, that kind of thing, some reading, and a bunch of other stuff. So let's start off with this. I want to make something called a desired velocity. And I want to be able to normalize. We talked about normalization earlier this morning when we did our lecture. We want to normalize a vector between the target and the position. That's what we want. And we want to multiply by max speed. That's what we want to do. So this desired velocity, we don't have this variable. So let's add it in and a getter and setter on the Starship game object. Let's do that now. So going back to the Starship game object, let's also add in the Starship CPP for a second. There it is. And what I want here is the desired velocity. So I'm going to put this down here. We'll say it's of type GLM vec2 because it's a vector2. It's a vector. And it's going to be called m_desired velocity. Okay, that's what my desired velocity is. Okay, and of course, what we need to put up here is a getter and a setter. Let's do that. So we'll say in the getter area, we'll say that it's going to return a GLM vec2 object, which is going to be called get desired velocity, just in case we need to get it. And we're also going to set the desired velocity down here. Set desired velocity. Right? And we're going to base it on the target, which is a GLM vec2 object, which is the target position. So we need the target position here. Okay? What I want to do now is scroll up to where it says Starship and go to here and then generate definitions by declarations, which is going to bring up these two things, just like last time. So it's going to generate these declarations here. And then, or definitions. So this is the two that I've created, get desired velocity and set desired velocity. For the getter, that's pretty easy. It's just going to be return m_desired velocity. That's pretty simple. And we can make this a const, just like we've done before. So this is all the same. Set desired velocity, though, is a little bit more difficult. And we're going to use this little code here to help us. So what we want to do is we want to say, I want to get the target minus my position. It's actually reversed, right? Multiplied by the speed, and we want to normalize these two values. Remember, normalization takes a magnitude of a vec2 and reduces it to normalized values between 0 and 1. That's what I want to do here. And I have a function for that I've shared with you inside of the util class. So if you go to core util.h, inside the util.h, I have a normalized function that I've written for you already. You don't have to work hard. And if you actually go to definition for this, you can see that Let's try that again. If you go to definition for this, then you're going to see that the normalized function, what it does is it takes the vector and it takes the length of the vector, and we divide by length, so the actual values by length, to get a normalized value between 0 and 1 for each component, for the x and the y component. And that's what the destination is. So that's what this little function does. It normalizes vec2 and stores the result in a new vector2 object. All right. So what we need to do then, when we use this function, we need to call the util class. And luckily what I've done is in the top of starship.cpp, I've already included it earlier. So let's use it now. So we're going to say something like this. We're going to say m_desired velocity is equal to util normalize from the target minus the current position. So target position minus the current position, right, which is the current position of my object. So that is get transform position, right, multiplied by max speed, right, this one. So that is the exact same line, like almost line for line, or almost the exact same thing as we saw here. That's all I've done. I've actually taken this little formula, and I've taken it, and I'm putting it right here. Let's make this target position const, because that ain't going to change. First steps. All right, so that's the desired velocity. What we want to do next is we want to take our steering. It says steering, and what that is we want to be able to, this is the steering vector. It's the difference between the desired velocity and the character's current velocity. So this is the desired velocity, and here's the current velocity. All right, so this desired, so this is the current, this is the desired. So we're going in this direction, but I really want to go in this direction. And that is the steering. So basically, instead of going this, I'm going to go this way, right? That's the difference. I'm going to get a normalized vector for this. So if I did this, and I go down in here where it says set desired velocity, then what I need to do is something like this. I'm going to say that instead of steering, let's do it this way. We'll try and do it in one. We'll say that get rigid body, right? Get rigid body dot velocity. That is equal to the desired velocity right, minus the current velocity. So that is I'm getting the desired kind of direction minus the current direction, whatever current direction and speed I'm going in right now. At the beginning, remember, I set this up so that we're starting off at 0. We're not even moving. Okay? So that is what this does. That's what the set desired velocity does. Okay. And just to show you this, let us output this. I'm going to include IO stream up top. So we'll say include, right, IO stream. Okay. And remember what I want to tell you about this IO stream. One thing I'm not going to do is also include these I'm not going to use a using statement, because using statements, again, are only Microsoft VC specific for the most part. So instead of using it that way, I'm just going to use the standard kind of like library like this. I'm going to say standard cout, and I'm going to say that the desired velocity, right, is equal to open bracket, and then the m_desired velocity dot x, and then plus this, plus dot y, plus this. Oh. Okay. So that's going to output my desired velocity every frame. Well, every time I set desired velocity, it's going to output the desired velocity. Now, there's inherent issues with this, right? But this is our start. This is where we start things off. Okay, so now that we have this little function, are you with me? Do you have this function? Do you have the get desired velocity and set desired velocity? Because I need to move on. Lyra says yes. How about anyone else? Anyone else have that? Daniel, you're good. Drake, you're good. All right, I'm going to move on, guys. So now that I have this, let's go back to placing.cpp. And in the update function, right, what I'm going to do is just do a bit of a hack, right? I'm going to say that, hey, m_p Starship, right? I want to, well, let's just print out the desired velocity. So we'll say that set desired velocity to m_p target. So wherever the target is, right, wherever the target is, I want to get the position from the target, and I want to use that as the desired velocity. And I'm going to print that out every update. Let's do that first. So let's run this and see what happens. Again, little changes at a time. I'm just moving it over here so you can see the code. Start. And you can clearly see that the velocity is 10, 0, which is what it should be. It is 1, 0, because that is the direction, right? Multiplied by 10, because 10 is the max speed. Now, what I can do is, because I set this up, I can move my target, and so too will the velocity change. For example, if I move my target up and down, you can see that the velocity will change, the desired velocity will change to the position of where this target is, so it'll go directly that way. Right, cool. So this is good, that's the desired velocity. So what about my current velocity? So my current velocity, right, is I'm gonna add on to my current velocity, my desired velocity. And what I'm going to do is I'm going to keep on modifying it until I get closer and closer to my target. So it might look something like this. m_p Starship, and then we'll say get rigid body dot velocity. Well, that's going to equal to m_p Starship, and it's going to be get desired velocity, right? So if I did this, then it's going to basically move or change my velocity to whatever the desired velocity is directly. Okay, I don't want to really do this yet. And then what I want to do is, if I want to move my Starship, I can use the movement pattern, which looks like this, m_p Starship. And I can say that get transform dot position, that's going to equal to my, we'll say plus equals, so we'll add onto the current position my velocity, m_p Starship get rigid body dot velocity. So if I did this, it'll add the velocity to my current position, and then it'll calculate the next position, the next position, the next position. Okay, that's what this will do. And this is pretty ugly. So let's move this into its own function by highlighting everything and right-clicking, going to refactor, extract, extract method. And what this will do, resharper will create a new method for me called move Starship, right? Again, most likely what I'd like to do in the future is take this function that I'm writing and include it inside the Starship class. For now, we're testing it here in our placing. And then here is move Starship. Move Starship can probably be made const because I'm not doing anything with it. And move Starship is being used right here in the update function. So it's a little cleaner than me having to include more stuff in here. Okay, let's test it and see if this works. So run. And when we go to, when it finally builds, when we go to our place scene, then it's just going to go here and stop. And what I can do is if I move this around, so if I move my target around, my Starship will move wherever I'm going here. But this is not really seek, is it? This is just moving towards where I am. It'll move, my velocity will just move where I'm going. So what's missing? What's happening here that is not cool? Right? Because I got my rigid body, I'm saying my velocity is equal to my desired velocity. So that's a problem, right? It's like I want to add my velocity to my Starship velocity. That's why I want to add these two together, right? And if I was to do that, if I said, let's do a plus equals here, right? Well, that's going to be weird too. Let's see what that does. So my velocity, I'm adding it on to my current velocity. Am I going to accelerate? And you're going to get this weird thing. So not exactly what I'm looking for. Not exactly what I'm looking for. And I don't really want to do this either, right? It's almost like I want to add my velocity on top of my current velocity first, and then go from there. And remember what I'm doing in my starship.cpp. My starship.cpp, I'm subtracting it. I'm saying take my desired velocity and subtract my current velocity, right? I'm getting a difference. I'm going to get a new direction. That's what this is. That's what's happening here. I'm getting the new direction of where I want to be, right? And I'm setting that to the current velocity. Again, this is maybe not correct. What we have here is actually something else, which is the steering. That's what the steering is going to be. This, right? Let's comment this out because I know this is working, right? This is my set desired velocity thing. And what I want to do is set up a term here to stop my Starship from starting off right away. And I want to do that in the CPP function, sorry, the GUI function down here. So right now we have this simple button that doesn't do anything. Let's change the simple button from my button to, we'll call it toggle seek. So toggle seek, that's the button that's going to appear in IMGUI, right? And what we want to do is, we don't need this part, we want a toggle seek method or some kind of toggle seek Boolean that we click on and off. By the way, instead of a button, we can also use a checkbox to, kind of toggle on and off. A checkbox might be a better construct than a button, but for now, because the button doesn't really give us any feedback. When I click it, it just goes, but it doesn't show me that I'm going or that I'm on or off. It doesn't tell me this. There needs to be better feedback, and that's why a checkbox might work better. Okay, well, let's see if we can find a checkbox to toggle on and off seek. Let's look at that. So if I go to Solution Explorer, and I'm doing this differently than I did the earlier class, and that's okay. That's just going to help you guys later anyway. So I'm going to go to IMGUI, and under IMGUI, there's this demo CPP function. And if I ever want anything, I can always look for it in here. This is an example of all the different kind of functions I can do, right? So if I Control F, I can search for something like a checkbox. So I want a checkbox, not checkbox flags, but actually a checkbox. Let's see if I can find a checkbox by itself. Here's an example of a checkbox. The checkbox has some kind of string followed by an object that is a Boolean that checks on and off the Boolean. This is actually really good. I'm going to grab this whole line of code here that's inside of my IMGUI demo.cpp, and I'm going to include this almost exactly in here instead of this button. I'm just going to comment out this button, and I'm going to put this in here. But we don't have this IO configure input cursor blink thing. We don't have that. So instead of that, what I want is an object that I create. So instead of this, we're going to call this toggle seek. It's going to be a checkbox this time, right? And then in the placeScene.h, I want a Boolean for this. We'll call these UI controls, and we'll have a Boolean that is M underscore B for Boolean toggle toggle seek. Okay. And what I wanted is for me to put that in here. So I'm going to say ampersand M underscore B toggle seek, and I get a bit of an error. And the error says, cannot convert const bool star to parameter type bool star. Why? Because of this. My GUI function is const. Let's not have it const for now. And then that means that I have to go into my placeScene.h and remove const from my GUI function. And if I did that, then you're going to see that this is okay. So checkbox M underscore B toggle seek, that'll turn it off and on. And then what I can do is, if it's on, I want to turn on seeking behavior. If it's off, I want to stop seeking behavior. So the way I can do it is, up in here where I have my move Starship, I can basically say, for now, right, if M underscore B toggle seek, then I want to be able to do this seeking behavior, which is pretty basic right now. Let's see if this toggle seek works. So let's press play and see what it looks like. And I'll come back and I'll show you the code one more time. All right, so start. It's not going yet, and you can clearly see that I don't have this toggled on. Once I click the checkbox, though, I can check it and uncheck it, and it's going to, if I uncheck it, I can move my target around. If I check it again, it's going to just move. If I uncheck it, it's stopping, and if I move it around, I can check it, and it's going to move where I tell it to go. All right, so not exactly what seeking behavior looks like because I'm missing a component. The component I'm missing is any forward thrust that this thing has in the direction that it's looking. I don't have this. This is like I talked about the beginning of seek, which is what I'm giving you right here. But notice what I did. I added some toggles here. And this is what I'm asking you to do. Try and figure out all the controls for assignment 1, put them in IMGUI, and make sure you can affect the objects in here. Yeah, the reason why it does that is because of what we did. Sure, let's go there. Hold on, Lyra. So down in here, all I did was I added a checkbox, right? By the way, you could do a button like this too. The button would look like this. M underscore B toggle seek, right, is equal to not M underscore B toggle seek. That would be the button version. If I want to do the button version, it looks like this. But there's no feedback this way. It doesn't give me a checkbox like this. So first we need to do this. I had to remove the const from GUI function and as well from the placeScene.h. So no const after GUI function, right? That enabled me to do this, okay? And then what I did was I took the toggle seek Boolean and I wrapped it around my movement function. So if I go up to my movement function, all I've done is I'm saying if it's on, then make it go. Otherwise, don't. Lyra, are you good now, or do you need more? Thank you for that feedback. All right, so yeah, that is the beginning seek. So let's go back to our little PowerPoint and see what we've done. We've talked about basic movement and how to make that work. And I talked about how that works for ships. We began the seek algorithm, and I also adjusted the IMGUI. This lab is done. So I know it's very short, but I want to make sure that you move forward with some of the stuff that you've done. What's next steps after this? These are good starting steps, but the next step is, well, what should really happen? So if my ship is here and it's moving directly where I'm looking. If it's here, it's going to move directly there. That's not the pattern. What I want to do is, if this is the direction of my target, and let's suppose that my ship, this is next steps, right? If my ship is not pointing east, but actually it's pointing up here like this, okay? And I have a thrust that goes in this direction, right? Then what I should do is, as I'm moving in this direction, then I should also add the velocity in this direction. So I'm adding this direction, this velocity, plus this velocity in the direction that I'm moving. So as I move, I'm going to modify my current direction, the look direction I'm going, so that it looks constantly at the target. In order for me to do that, I need to start thinking about what I've already given you. Remember that the Starship is an actor. Because it's an actor, if I go to definition, this is hints, I already have current direction. I already have current heading. That's what I already have, right? So if I have current direction and current heading, then really what I can do is I can say my current heading is an angle. My current direction is a vector. So I can take my current direction, and that's where I'm going to add my velocity. I'm going to add my velocity to my current direction as I move forward. Because remember, what's happening with my current direction, if I go to set current direction, okay? So if I set current direction, go to definition, I already have this for you. It says take my new direction and make it my current direction. But my current heading, right, what happens is when I change my angle, then I'm going to change my direction by taking my current heading from an angle perspective, multiplying it by deg to rad, so convert it to radians, right? Convert it to radians, and take the cosine of that to give me my new x value. That is when I change my direction. And that is going to be my new current direction is going to be a normalized value between 0 and 1, right, where I'm going next. And I should take that current direction and multiply my max speed in order for me to move to the next one, the next one, the next one, or multiply my, that's what I'm doing. If I did this, then I would get wherever I'm going, that is going to be where my, I'm going to be going in the direction I'm looking, which is the next step. So try and see if you can do that on your own. That's kind of homework for you guys. And then when we're going to get back next week, we'll finish off seek, and then I'll start the other functions for you. Okay? So that's it for this week. Any questions for you guys before we move on? So lots of stuff we did today, guys, and lots of learnings. Hopefully you guys are getting more comfortable with the framework. It's going to take time. And by the end of this semester, you should be fairly comfortable with using this thing. So when we do things with physics, you'll be, kind of firing on all cylinders in the right direction. Any questions at all before we stop for the day? Oh, yeah, screenshots. Thank you for that. So for the lab, what you want to do for the screenshots is you want to take, kind of positions of different places of your scene. So you can take a screenshot of this. So starting positions, right? So show me that this thing can work for you. And then, maybe modify the position of your target and then toggle seek on, right? So you see what that looks like. Even if it does something like this, take a screenshot. Show me the positions. And you can always toggle on and off this stuff again. By the way, if you keep it toggled on, it'll move with your cursor, no matter where you put it, right? So no matter where it is right now, it kind of follows your target wherever it is. And this is not exactly what seek is. Not quite. So try and move your target around different places, right? So maybe make it kind of go down here, right? Show the target is different. So you're showing this action. It's not a lot. And then just toggle seek on. What does that look like? How should it really work? This should rotate in the direction that this target is and move towards that target that way, right? It should rotate every frame or some amount towards the target. That's what it should do, right? As it's moving in the direction that it's going to do. So it's going to rotate to the left or rotate to the right. So things that are missing are the things we're going to add next week. There's no homework. I don't expect you to do the homework. We're going to do it next week. I want you to think about it. If you can do the homework, Lyra, all the better, but I don't expect it. We're going to do it. I want you to start thinking about it and start trying it on your own and see what other weird effects you get. But for all I need for today is this, what we've done together. Okay? Okay? Drake, you're saying just tested it and the ship is shaking like crazy. We're moving to the target. Well, again, take a look at my code versus your code. I'm going to push this up online. That's one thing I haven't done yet. Let's do that now. So under Team Explorer, I'm going to go to Git Changes, and I'm going to say added basic seek algorithm, or we'll say beginning, instead of beginning seek algorithm, right? Which is really what I'm not finished yet. It's just the beginning of it. So I'm going to push this up, commit all, and push. Is it shaky because people kept the stuff in update? It could be shaky for a number of reasons. But remember that my set desired velocity is here. Could I put this set desired velocity in my update function? I could, but then where would I get the target position? So there's some assumptions I'm making here. We can optimize what we have. But remember, guys, my motto, make it work, then refactor. Then optimize. Don't optimize right from the beginning. Just make it work, make it go. If you can make it go first, then you can start thinking about, how do I optimize? How do I make this better, right? So this is the thing. So the first thing we did was did this part. And by the way, if you want to check my code versus your code, you can always go back online. You don't have to wait for me. You can go up online and go to this and refresh. And you're going to see that I have 4 commits. And you can always go into the SRC folder. And my code for everything is right here. So if I wanted to check the spaceship or the Starship, starship.h and the starship.cpp, it's right here. It could be, Daniel. Could be that you're right. It could be that it's shaky all the time. But, it really depends on where it is. Like, for example, if I make it an angle, so if I start this off and then I put this at an angle, let's start this off like up here, right? Then you're going to see that from here to there, it's going to be more shaky than before, right? You just can't see it, but see where it stops here? If I move it, right, it's going to shake. If I move it, it's going to shake. What happens when I go negative? That's interesting. It tries to wrap, doesn't it, right? It kind of wraps, my object kind of wraps, right? Same thing goes with this. If I kind of take it further, it doesn't go much further than this. I can make it chase, the Starship will chase wherever the ship is going to be. Wherever the target is, the Starship is going to go. Okay? And there's a bit of shake happening. Maybe you guys can't see it, but it's happening on my end too, right here, depending on where I have it and how far away it has to go. So don't worry about it. It's because there's issues. There's issues. We haven't finished off the algorithm yet. This is just the beginning. So here's my recommendation. Read what it says here. Try and start reading this paper, right? When it talks about what to do. And also take a look at the PowerPoint, because the PowerPoint also gives you hints on what to do. The PowerPoint, if you look up at seeking behavior, which is here, it actually tells you the exact same thing we kind of did, right? The difference is we have a steering structure that I'm not using. But it's okay because we're doing almost exactly the same thing. Instead of steering, we have rigid body. Okay, guys, that's it for me for today. Thank you so much, and I'll see you guys next week. Good luck and have a great long weekend. See you guys next week, Thursday. Take care. I'm going to stop kind of sharing on YouTube now. Thanks so much, guys.